Okay, so imagine you were performing an experiment. You decided that you would roll a standard cube 35 times to collect your data. Draw a dot plot that shows the distribution of values you might expect for the rolls. So, for instance, if we rolled a cube 35 times, we might get something like this. We might get, 1 1, 2 6s, one of each, one right here. Something like this. So we have at least one roll for each number, okay? And then we would have like a bunch for one number and then a few for the other, okay? And the reason why that's going to happen is, over time, we'll hit each number, but we're going to have some tendencies. You know how like you roll it and your hand kind of faces one way? Hopefully you're being a fair person. But, you roll it and then it kind of just lands on the same number every single time. So you might have like 5s and 6s rolled multiple times, okay? So coming down here to the next one, if you rolled the number cube 1 million times and found the mean of all the values, what do you expect for the mean? Well, if we have numbers 1 through 6, okay, and we have a equal representation of like 1, 2, 3, 4, 5, 6, we have like at least one roll for each of those, okay, and then we have a bunch of 6s, and then we have a bunch of 2s, then we're going to roughly be around the mean of like 3 to 4, okay, because like a 1 and a 6, well, if you find it in the middle, it's going to be roughly around 3, 4, right? Okay, so let's actually get into the information for today. So for each situation, you're going to find the standard deviation of the sample means. Use the standard deviation of the sample means to estimate the margin of error. Use the sample mean and margin of error to create an interval that likely contains the mean of the population. Okay, so what we're going to do is we're going to open up a Desmos. We're going to open up the Desmos graphing calculator, and we're going to insert these numbers into this Desmos graphing calculator. So I would, if you're at home, okay, I would definitely try this on your own. And I'm going to split my screen really quick. Okay, so I would try this on your own. So I would open up a Desmos tab. Okay. So remember, last week we talked about this. But how you would create a table for this is you would hit this little add button, hit table, and then you're going to type all of these numbers that they give you into a single column. So we're going to get 2.38 plus 2.42 plus 2.64, 2.35, 2.65, 2.47, 2.67, 2.59, 2.63, and then 2.41. Okay. And 38. Okay. So now that you have that, what you're going to do is come down to the next little line. And you're going to hit this keyboard. And we're first going to find the standard deviation. Okay, so we're going to go functions, stat, standard deviation. And then we're going to type the name of this list. So that's going to be x sub 1. And so our standard deviation is going to be 0.126, or you could just say 0.13. Okay? Our next step is to find the margin of error. Margin of error. So if you type into Google and you say, hey, margin of error formula, you're going to find z critical multiplied by the square root of the standard deviation squared divided by your sample size. Okay, this z critical is going to be 1.96 because we're going to talk about the 95% confidence level, which is going to result in a critical z critical value of 1.96. Now your teacher probably told you the z critical is going to be just 2. And that's okay since we're actually just estimating, right? We're estimating the margin of error. Okay, so z critical is going to be 1.96 or 2 square root of sigma squared, which is going to be 1.126 squared, divided by my sample size, which there are 10 numbers right here. Okay, so I'm going to take that mess and type it in here. So I got 1.96 square root of 0.126 squared divided by 10. And so that's going to give you a margin of error of 0.08. The last little bullet says that we're going to use the mean and the margin of error to create an interval that likely contains the mean of the population. Okay, so we're going to first find the mean. Okay, so we're going to go to functions, we're going to hit stat, we're going to hit mean, x sub 1, which is going to give us a mean of 2.521. So in order to create this interval, what you're going to do is you're going to take the mean and you're going to add and subtract the margin of error. Okay, so we're going to take the mean, which is 2.521, and we're going to add the margin of error, and then we're going to take the mean and we're going to subtract the margin of error. So this is going to give me an interval of 2.441 to 2.601. And what this interval is saying is that the true mean of the population is going to lie somewhere inside of this interval. Okay, so we found the mean of our sample. We found the mean of our sample, which is this 2.521. But the mean of the population is going to be just a little different. But it's going to lie within 2.44 and 2.6. All right, so coming down to number 3, a company producing baseballs selects 10 baseballs at random 9 times a day and measures the diameter in centimeters. The mean of each of the 9 samples of 10 baseballs is shown. Okay, so we're going to type each of these into our little table. Okay, so then we're going to find the standard deviation. So we're going to go to functions, hit stat, hit standard deviation, say x sub 1, and that's going to give us a standard deviation of 0.21. So standard deviation is 0.21. Okay, and then we're going to find our margin of error by taking our z critical, multiplying it by our standard deviation squared, and then dividing it by our sample. So we're going to take 1.96, or if your teacher told you to, that's fine. Okay, and we're going to take the square root of 0.21 squared divided by our sample, which there's only 10 numbers here, right? Okay, so we're going to type that into our calculator. So we're going to say 1.96 square root of 0.21 squared divided by 10. And that gives us a margin of error of 0.13. Okay. And then in order to do the next part, which is finding the interval, we're going to find the mean first. Okay, so we're going to come in here and we're going to type functions, stat, mean, x sub 1. And that's going to give us 7.36. Now, in order to find that interval, we're going to take the mean and add and subtract the margin of error. Mean plus or minus the mode. Okay, so in here, I take 7.36, add 0.13, and then I'm going to take 7.36 and subtract 0.13, and that's going to give us an interval of 7.23 to 7.49. So that means that the true mean is going to lie somewhere between these two numbers. So it could be 7.3 or it could be another number. Okay? Alright, so after you take all of these numbers and you type them into your calculator, you're going to click on standard deviation, and that's going to give you 1.52. So on my paper, I'm going to write 1.52. For your margin of error, you're going to do 1.96 times the square root of 1.53 divided by 15, and that's going to give you 0.77. For your interval, you're going to find the mean, which is going to be 9.45. You're going to add and subtract the margin of error, which is going to give you 8.68 to 10.22. And that's it. So coming down to your ticket out the door, what I'd like for you to do is read it over, okay, and then highlight or just write down all the values that are going to be inside of the interval that's created when you take 105 and 21 for the margin of error. Okay, so I'll give you a couple of seconds to finish that up. Alright, so if I'm creating an interval, I'm going to take the mean, which is 105, and I'm going to add and subtract 21 to it. Okay, so I'm going to go into my calculator, and I'm going to type, I'm going to take 105, and I'm going to add 21 to it, and then I'm going to take 105 and subtract 21 from it, and that's going to give me 84 to 126. Okay, so 84 to 126. So now what I'm going to do is I'm going to ask myself, all right, are these numbers within that interval? So they are inside of it. Okay, so for instance, 76 is not. 87 is. 105 is. 113 is. But 154 is not. Okay,